Two radio antennas are separated by a distance of 310 meters, as shown. They're going to simultaneously broadcast identical signals at the same wavelength. A radio in a car traveling due north receives these signals. If the car is at the position of the second maximum, what is the wavelength of the signals? Alright, so these antennae have oscillating charges in them that are going to send out waves. And the blue rings here represent the crests of the waves. Those would be the maximums. The minimums aren't shown. I'm going to draw the situation just a little bit out of scale so that we can see what's happening. If we look at a point that's symmetrically between the two antennae, and we draw a sine wave, then what we would find is the sine waves emitted by these two antennae are identical. So what happens is they're in phase when they reach that point. If we move up a little bit on the axis, they're not going to be in phase anymore. But there will come a point where they come back to being in phase again. Now, how could something like that happen? So what we would need to have happen there is there would have to be a point where the path length difference between the two was a multiple of the wavelength. I mean, if the one antenna completes a certain number of cycles, the other wave would have to complete more cycles, but it would come back such that they were both at a phase of, let's say, 0 degrees when they reached that point. Now, how could that happen? It would have to be that the length of the one and the length of the other had differed by exactly one wavelength, so that the other wave had enough extra path length so that it got in one extra oscillation. Now, the way that we draw this is we draw the distance between the antenna and the point in question, and then we try to see how much longer is that other path. It'll be longer by a certain distance. And that distance needs to be a full wavelength. If it is, then when one cycle is completed, then when these waves proceed forward to that point, they'll be in phase. That's what we're looking for. This point here is called the central maximum. That's a point where just by symmetry, they're going to line up and they'll be in phase. And when the waves are in phase, we would get the loudest or clearest signal. The next point where that happens is called the first maximum. And they will be again in phase and we'll get a clear, loud signal. If we go up farther, it'll actually happen again and we'll have a second maximum. And what will happen there is the path is long enough that two wavelengths will complete. So two extra wavelengths will complete in the longer path than in the shorter path. And what will happen is they'll come back in phase yet again. So in order to solve it, we'll have to use a little bit of geometry and trigonometry here. This path length can be called L1. And the other path length can be L2. We can create right triangles for the purposes of figuring out how long each of the paths is. We know the base of each triangle is 1,000 meters. And we just need to figure out what the height of each triangle is. So there's going to be a certain height for this one, and then there'll be a different height for the other one. Now they're saying here that the distance of the car from the central maximum is 400 meters. And we also know that the distance between the antenna is 310 meters. So if we just cut that in half here, then we're going to have 155 there and 155 there. This distance here is 400. Therefore, we'll have 555 from this point to that point. And we'll have 245 there. So we have two triangles to work with. There's this one of 245 and 1,000. And we have another one which is 555 and 1,000. All right, so to find L1 and L2, we're going to want to use Pythagorean theorem. It's 1,030. L2 will be 1,000 plus 555. That's 1144. Now, since we're talking about the second maximum, it implies that the difference, so the difference between the paths must be 2 times the wavelength. So what I would do is say that 2 times the wavelength equals L2 minus L1. And if we solve that, we get 56.8 meters.